All right. So welcome to CS50's third annual Prep and Practice for Technical Interviews. As you all know, the goal of this session is really to better prepare you as you go into maybe your first or your second year or third year of interviews, just feeling more comfortable, more confident, more aware of what kinds of questions you might get asked, and also to get you some feedback and some thoughts on how best to structure resumes, things to do and not to do. And we're super excited to have two of our friends from Quora here, Ryan and Tommy. Tommy, of whom was one of CS50's head TFs just a few years ago. And if you took CS50 a couple of years ago, odds are you were using a lot of the software that Tommy himself wrote. He's been at Quora since, doing amazing things in mobile and software engineering more generally. And so we'll now turn it over to them to take us away.
Thanks. So as David mentioned, my name is Tommy. I used to be one of the head TFs for CS50, and since then I've been at Quora. I've been on a bunch of different teams. I've worked on mobile, I've worked on performance. I'm currently leading our platform teams. So platform you can think of as basically internal engineering and productivity. So we work on things like tools for full stack engineers and distributed systems for machine learning engineers. Basically a lot of the foundational stuff that a lot of Quora is built on. And I'll let Ryan introduce himself as well.
Yeah, so hi, I'm Ryan. I'm a software engineer here at Quora. So I work on our machine learning teams. So I kind of focus on those emails you might get from us, our digest, our main feed. So working on the ranking algorithms and the performance of the systems that drive that at Quora. Yeah.
Awesome. So as David mentioned, today we're going to go through a workshop focusing on all aspects of the technical interview. Technical interviewing can be really intimidating and scary. There's not a lot of sort of direction of what's going to happen. So really the goal of this workshop is to help you understand sort of all different parts of the process, what's going to happen, what you can expect, and then lots of strategies and tips and tricks along the way to help you prepare and be successful in those interviews. So this is what we're going to be covering today, basically sort of an end-to-end process for the interview. So things to do before the interview, how to prepare for the interview, during the interview itself, what to do after the interview, and then we'll have lots of time at the end for Q&A. If you have questions, anything specific to your situation, happy to answer those questions. We'll do a couple of mock interviews as well. So to start, let's talk about before the interview itself. So before interviewing, the first decision that you clearly have to make is choosing companies to interview with. You probably don't want to interview with every single company out there. You don't have the time. You're probably wasting their time as well. So this is sort of an important first step during the interviewing process. So I have here 5 questions that you probably want to ask yourself as you're choosing companies. So the first one is, what are you looking for? Whether it be an internship or a full-time job, I think everybody is looking for different things. So some people in their job really want to focus on impact and want to work at a company where they can have a really strong impact on the product, not just work on some small corner of some larger system, but really take a lot of ownership, drive a lot of things themselves. Other people want to focus on learning. Maybe it's your first internship and it might be hard for you to jump in and have a lot of impact, and you just really want to focus on learning a bunch about the industry, sort of soaking up as much around you. Maybe you want to think about work-life balance. Maybe you want to go live in a new location for the first time. Maybe you're like me, you're from Boston, you've never been on the West Coast before, you want to try a West Coast internship, want to try a New York City internship. That's all fine. That's something that some people want. Some people care about money. This is something that matters for some people, not to other people. And none of these is really more important than the other. So a lot of times when you're interviewing, you'll see a lot of sort of peer pressure from your friends of, oh, you've got to interview at this place, or you can't go work there, that's so lame. I wouldn't think about that. Everyone is really, really different, and what everybody is looking for out of an internship or even their first job out of college is really different. And so recognize that and make sure you're asking yourself what it is that you're individually looking for. So second question you want to ask yourself is, would you be excited to get up every day and work on this product? Since that is something you are going to be doing, is getting up every day at 9 or 10 a.m. and working on this product for a long time. So you want to make sure that you're actually excited to work for this company. So in many consumer companies, it's really easy to just go use the product. If you enjoy it, it's something you could see yourself contributing to and being excited about working on. That's a great sign. Other companies, their product might not be super available, especially if they're in the enterprise space, or you're working on something that is a little hard to access, or you wouldn't use much as a student. That's totally fine. Just learning about the company's mission and what their high-level goals are as a company and what they're trying to do in the world also sort of paints a picture of what your day-to-day work is going to be like if you were to work there. So these are always super publicized online, and their about page or whatever. The companies are pretty public about their mission and explaining what they're trying to do to the world. So the third is whether or not you'd be excited to get up every day and work with the people at that company. So that's another real thing. You could be working on your favorite product, your favorite product in the world. But if the people that you're working with, you don't like or you don't collaborate well with, that's not going to be a great experience. So that's a really important part of the equation. And the best way to get signal on this is during the interview process itself. You're guaranteed to be meeting with several different people from that company during the interview process. And so think about how those conversations are going. Every interview will say, do you have any questions for me about the company or about my journey here? Really, really, really take advantage of that. I've had so many people when I say, do you have any questions for me? They just say like, no, I'm tired. Not a great answer, one, from my perspective, but also from theirs, because they're really missing out on an opportunity to understand what it's like to work at Quora or work with me or work with anyone else on the interview loop. So this is also a really important thing. This is the thing that's a lot harder to get a sense of. You can't just go to Quora.com/careers and suddenly understand what it's like to work with the people there. You can only get this by interviewing, so make sure you capitalize on that opportunity. Also, once you have an offer, this is another really, really great opportunity to talk with a lot of people from the company. If a company gives you an offer, that means that they want you to join, and they're going to put in a lot of effort to make sure that you join. You're probably going to have offers from 3 or 4 different companies who are sort of competing for you to join their company. So that means, if you're in that situation, you've got a lot of leverage. You can just sort of ask, hey, I'm thinking about these different things. Do you mind if I talk to, some PM or your head of business or someone on the design team or some engineering, the head of engineering or something? If companies gave you an offer, they're going to be really willing to put in that time for you to meet other people from the company where you can ask them questions and learn about their role, how you'd fit at the company, what that day-to-day is going to look like. Oftentimes, recruiters will ask, hey, is there anyone you want to talk to? Can I set up these conversations? Some companies call them reverse interviews. Some companies call them cell chats, which is a little more direct. If a recruiter doesn't ask, just ask them. Chances are they'll be really willing to do that for you. So fourth, you want to make sure that the things that you value align with things that the company values. So you can think of company values as basically what some company values more than other companies out there. So for example, probably a lot of companies value don't steal stuff. Not all of them, but probably most of them. And that's not really a value because every company sort of values that. So when companies talk about their values, they're talking about what differentiates them from a lot of other companies out there. So again, these are really easy to find for basically any company. Just looking at their careers page, they probably shove them in your face during the interview process, which is good because then you know what they are. So here's an example. So these are Quora's 5 values. So one, everybody at Quora is really mission first. We really believe in putting the team and the company over yourself. So the achievement of a team and the company is much more important than your own individual achievement. Second, we value drive. So people who take a lot of initiative, have a lot of autonomy, don't sort of sit around and wait for someone to tell them to do something. They go off and do things themselves. Value agility, so the ability to quickly pivot and change our approach or direction to solving some problem. We value awareness, so we're a very data-driven company, so being aware of different data, being able to make rigorous data-driven decisions. And finally, pragmatism, so people here are not perfectionists. They're okay cutting corners, delivering something that's 80% as good, so they don't waste the remaining 20% of the time. So those are Quora's 5 values, and it sort of paints a picture of the type of people who work at Quora and what it would be like to work there. And these are not sort of objective truth. This is how Quora works. Think about how you work. Think about how you value, and see how much that aligns with each company that you're interviewing with. In some cases, you might see a values mismatch. You might, for example, really value transparency and understanding everything going on at the company, and some other company might not value transparency at all because they're really big and they can't share all that information. So that's just a values mismatch, and that's totally fine. It's not a poor reflection on you or the company, probably. But the more you're asking yourself that question, you can sort of understand where you're going to fit at different companies. So finally, a really easy question to ask is just how big is the company? Because your experience as an intern or a new grad is going to depend a lot on the size of the company. So this is a cool table that Dustin Moskovitz, who's the founder of Asana, put together. So I can't claim to have created this, but it's really good. And you can basically think of a lot of companies in the tech space, in the Bay Area in particular, as having categorized into one of 3 buckets. The first one is a really small company. So this is your seed, Series A, Series B-ish company, probably around 50 people. The second is the mid-sized company. So this is sort of Series C or D-ish. Somewhere in the range of 50 to 500 is sort of big here. It's like 50 to like 300 ballpark. And then the last is just everybody else. So sort of like the large companies. This could range from some company like Square, which is like 2,000, to some company like Google, which is like an order of magnitude more than that. And then here's sort of like the axes of how things are going to be different. I'm not going to walk you through this entire chart. So one good example is autonomy. So at a really small company, this could be a company that's like 3 people. You basically got to do whatever. Some companies you have to like go assemble your desk on the first day, or like go be a salesperson on one day and then be a PM the next day. And that's really appealing to some people. But if you're the type of person who just wants to go and learn, this isn't necessarily a great way to learn, because you sort of have to figure out everything yourself and maybe may or may not get feedback. At a mid-sized company, the autonomy is less than that, but still not too small. So basically, teams are given some high-level mandates. So here are your team's goals for the quarter. I'm not going to tell you how to achieve those goals, because I got to go worry about something else. It's sort of your job to figure out how you're going to hit this metric or ship this product. But you know that you have to go hit that metric goal or ship that product. And then finally, at a really big company, you have a lot less autonomy. You're just sort of given a to-do list and say, go. You have a very clear list of tasks. You can evaluate your success very easily. Did you do the tasks or not? So there's a pretty big range there. I think another one is the mentorship one, since this is a lot of what new grads and interns look for. So at a really small company, there's going to be basically none. You don't have time for that. When you're a really small company, you're trying to ship a product, you might not exist next week. You don't have time for a lot of mentorship. Maybe that's okay. Maybe it's not. At a mid-sized company, there's some structured mentorship. On day one, you'll probably get assigned a mentor. Some companies have sort of a boot camp process where you can try a bunch of different teams, but ultimately, focus on delivering some project later. And then at really large companies, they have these really established programs. I think, for example, Facebook has a program called Facebook University that's a very structured learning process. It's explicitly sort of learning driven. And these really big companies, they have time for that. They can make that investment because they have many more resources. But companies on different ends of the spectrum can invest in various mentorship. So take a look at this chart. There's lots of other ones there, but those I think are 2 good ones to highlight. So let's jump into resumes first, since this is sort of something before the interview process, as you're going to be submitting your resume. So resumes are not that important. A lot of literature out there suggests that resumes are extremely important, and you've got to spend a ton of time getting the wording exactly right and make sure you use like a 12-point font space. This font is like a 13.5, whatever. So resume is not that important. So to start with the question, who has a guess for how long me, as a hiring manager, is going to spend looking at your resume? Yeah, just shout out. 5 seconds? 10. 30. Okay, so people are a little aggressive. I say on average I spend like 30 seconds. 5 seconds I can like say good font, but I can't actually read any words. So we're not that bad. We spend around 30 seconds on a resume. I think if we'll spend more than that if something looks interesting or we want to dive a little deeper. But we're not going to spend a ton of time on this. So keep that in mind as you're designing your resume. If you have the choice between practicing some new interview problem or like spending 2 hours on your resume, definitely don't pick the resume. So I have here 10 easy rules that if you follow them, your resume will probably not be bad. And again, that's your goal. So here we go. Rule number 1, 1 page. There are absolutely 0 exceptions to this rule. Super senior engineers, people who have been in the industry for 20 years, the inventor of Python, for example, their resume is 1 page. If the inventor of Python can get it on 1 page, you can too. Do not break this rule. I'm not going to read past the first page. Second, make it really easy to skim. If I'm looking at your resume and I'm struggling to see where you've worked or where you've done or what you did, I'm just going to give up. I'm only spending 30 seconds on it. You've got to maximize the efficiency of my 30 seconds reading your resume. So just make it really easy to see where'd you work, what'd you do, what year are you looking for an internship or a new grad position, which I can just infer by a graduation year. You don't need to tell me that. Just make it really easy for me to skim in 30 seconds. Third, your contact information should be the easiest thing to find on your resume. The whole point of giving me your resume is so that I can contact you later if we want to move forward with the process. Some people don't have any contact information on their resume. Some people put it in a really small font at the bottom, and I have to search for it, and then I get annoyed, and that's not good for you. So make it really easy to contact you from your resume, because that's why I have your resume. So this is sort of the ones. So fourth, make sure you're highlighting specific accomplishments from past internships. So, on one, some people say, I worked on this team. okay, great, I don't really know what you did. That doesn't really pique my interest. But if you say, I worked on this internal tools team and shipped a new tool to a team of 50 that increased productivity by reducing this bottleneck by 30%, that's much better. It's more specific. I can see what you're actually doing, and that's going to make me more interested. Obviously some companies have, confidentiality rules or, sign an NDA that prevents you from doing this. So don't break any confidentiality rules here. But a lot of things, like some high-level metric, or you could say, I 2x the throughput of this system. If you don't say what it was before and after, you're probably not breaking any confidentiality metrics. So fifth, include interesting personal projects. So if you're working on some side project, maybe you're a member of a student group or something, and you develop something on your own or with some friends, definitely include that on your resume. Do not include standard final projects. It's pretty common that we'll be at a career fair and it's really clear what the final project for some intro class is because 50 people built like collaborative Pong or something. That's not a side project, and it sort of looks lame because it's sort of introduced like, oh, what else did you even do? It's probably nothing. So I wouldn't advise doing that. But if you do have interesting personal projects, maybe the final project was more open-ended and you could build something that wasn't just sort of the standard templated thing, include that. But don't just include like, hey, I did like CS50 problem set 3, which some people do, so don't. And I know what problem set 3 is, so definitely don't. So number 6, do not have charts or ratings next to skills. This is egregiously common. There is absolutely no value in telling me that you are like a 3 out of 5 team player. So which again, people do. So do not do that. There's absolutely no exception to this rule either. I don't care what rule you're, just don't do this. 7th, you don't need an objective. A lot of people at the top of their resume say like, my objective is to seek a challenging position in the field of software engineering where I can apply my skills and have an. I don't care. I know. You're wasting space on resume. I don't read it, and if I am reading it, it's probably not because I'm interested in it. So don't include that. You're wasting space. Similarly, a lot of people put in their resume somewhere like references available on request. Again, you're completely wasting space. I know. If I want a reference, I'll get one. You don't need to like tell me that they're available upon request. You're wasting space. You only got a page. So number 9, if you don't have a professional-looking email address, just create one. I get a lot of ridiculous-looking email addresses that people had like in high school very clearly or something. Just first initial, last name, something. It's really easy. You look really silly if you don't do this, so just do that. And then finally, if you have relevant links, so maybe you're a LinkedIn that's filled out and looks good, if a GitHub contains some personal projects, those are great to include, especially 95% of resumes we're getting digitally, so we can click on links. If you're printing out a resume, links aren't that great. But include them. It sort of allows me, if I'm interested, or if I want to, maybe I'm interviewing you in 5 minutes and I want to like sort of get a sense of what you've been working on, I can click through to your GitHub, say, oh, this thing looks cool, maybe we can talk about that for a few minutes during the technical phone screen. So if you have them, include them. OK, so we have 2 example resumes. So I want you to tell me, based on those 10 rules, what is good and what is bad about this resume. So feel free to raise your hand if you have something good or bad. Yes?
It's good because it's really clear where he worked before and all of his positions really clear.
Yes, it is very easy to skim. You can see clear headings. Here's his experience. He was the CEO of something. He's got a hell of a career path. You can see his education. It's really, really easy to skim. So that's definitely good. Yeah?
Contact information's right there.
Yes, contact information, very easy to find. He has these nice icons in case it wasn't clear that the string of numbers is a phone number, but it's really easy for me to find. Yes? 1 page. Excellent. Did not break the 1-page rule. That's the easiest one to not break. Yeah?
Bad because of the skill.
Yes, this is what I mean by skills rating. This is ridiculous. This person is a 3 out of 5 team player. It's a little blurry, but that is literally what it says. This is a complete waste of space, and I'm not even sure I want to work with a 3 out of 5 team player. I think my bar is probably like a 4. So this is totally waste of space. Other stuff. Good or bad? Yeah? Yeah, the photo's sort of useless unless you're like an actor and trying to get, like an acting role. You probably don't need, this is not going to have any bearing on my hiring decision. Again, wasting space. How about one more? Yeah.
There's a lot of the profile, there's a lot of big paragraphs.
Yeah, so that's exactly what I mean by an objective. So I don't care. I didn't even read this. It could say Lorem Ipsum for all I care. I don't read this. Do not include this on the resume. It's a total waste of space. Okay, so that's resume number 1. How about resume number 2? Good or bad?
We
Yeah.
got some more
Yeah, we got some. This time they're not stars. We got a continuous scale instead of a discrete scale this time. But again, really, negotiation is, I don't know, 4 out of 5, not great. Other stuff, good or bad? So we got it's sort of similar. So I think this is like sort of easy to skim. You've got this weird, like, the content sort of flows like this, which you probably don't want. There's also this discrete scale down here, which is lame. Again, like the headshot, not great. Contact information is very easy to find. The content here is actually pretty good. There's like very specific metrics, like increase CSAT by 25%. So that's actually pretty good. But again, there's sort of a lot of unnecessary stuff on that resume that breaks the 10 simple rules. OK, so that's it for resumes, because we're not going to spend a lot of time on it, because again, it's not that important. So let's move into the types of interviews. We'll have time for questions at the end, actually. We're saving a bunch of time for that. OK, so let's just talk through some logistics first. So with interviewing, start interviewing as early as you can. It's pretty common for interns and new grads to interview sort of like late summer, early fall. So basically now. A lot of people will actually interview for like job I+1 or internship I+1 during internship I. So like over the past summer, we interviewed lots of interns for like the next summer, so they wouldn't have to like fly out. So some people do that. Excuse me, you don't have to. As long as you're sort of starting around now. If you haven't yet, you're okay. You're not like in trouble yet. But I wouldn't wait 3 or 4 months more to try to find an internship. Something else to do is plan interviewing into your schedule. Interviewing is basically another class. So if I wouldn't advise taking like 5 classes, like 2 of which are really hard during the same semester you're trying to do recruiting. You're going to have to have to make trade-offs against one of them, and you don't want to do that. So just sort of plan this into your schedule. Be aware that this is going to take a lot of time, particularly in the fall. And also look for programs that are targeted for your year. So like I mentioned before, but a lot of these larger companies like Google or Facebook or Microsoft, they have programs targeted at freshmen who have never had an internship before. If that's you, sort of, you've just taken a couple CS classes, you're, haven't had an internship before, those are the programs you should look for. If you don't, you try to, apply to these other programs, you're going to be competing with juniors who just have, 2 or 3 years more experience on you, and you're going to have a lot harder time being successful in those applications. So try to, at career fairs, try to talk to recruiters. Say, hey, I'm a sophomore. Here's my experience. What roles do you recommend I look into? Or even explicitly asking, do you have roles for freshmen? A lot of these big companies will say yes. A mid-sized company like us would probably say, well, we don't have a role just for freshmen, but we also hire freshmen if they're great. A small company might just say no. So try to have that conversation with the recruiter early on, so you don't end up on the wrong track. So basically, what the process will look like from end to end. Many companies will start with a coding challenge. So they'll sort of give you a technical problem. There's a lot of like different products out there. You'll probably have like 30 minutes or so to write some code. It'll get sent in to some auto grader, which will notify the recruiting team if you did a good job. And you'll probably take around 30 minutes for these. Make sure you sort of set aside sort of a quiet space and you actually you can solve the problem. Some companies don't have this, and those go directly to a technical phone screen. So this will be 45 to 60-minute conversation, usually with an engineer. For a lot of new grads or interns, it could just be some random engineer at the company. It could be an engineer who actually works on the team that you're applying for. It just sort of depends on those tracks. If that goes well, then some companies will do a second phone screen. Other companies will bring you directly to the on-site. The on-site portion, again, it's going to vary by company. You should expect around 3 to 5 different conversations. Again, each of those is going to be 45 to 60 minutes each. You'll meet with lots of engineers if you're applying for an engineering role, but you might also meet with someone like me, a hiring manager, maybe a designer, a PM. Again, it's really going to depend on the company and the team that you're applying for. But that's basically what you can expect for an interview process from end to end. So here are 5 types of interviews that you're probably going to encounter during this process, and I'm going to briefly walk through each of these. So the first one is my least favorite, which is the algorithms interview. It is unfortunately for me, the most common for interns and new grads. So an algorithms interview is basically a technical problem where you're going to be given some problem, you have to write code for a solution, but the problem is more about discovering the algorithm and getting to that high-level solution than it is to actually code it up. So for example, we might ask a question where the algorithm is sort of hard to come up with, but once you come up with it, it's like trivial to write out. It's maybe like 5 lines. It's some crazy like recursive cool thing. And the actual hard part is coming up with that algorithm. So if you find yourself in an interview taking a really long time to come up with the algorithm, you're sort of like stressed because you haven't written any code yet, it could be OK. That could be by design. The problem could be you're supposed to spend 20 minutes thinking of a solution and brainstorming, and then just 5 minutes sort of writing it up, and then it just works. So just be aware that that's sort of a class. When you're solving these types of problems, and this is the one we'll focus on the most today, try to optimize for both time and space complexity. Something you shouldn't do, though, is right out of the gates try to find the absolute best solution. It's OK to start with maybe a naive solution, a quadratic runtime or exponential runtime that isn't like the optimal solution. But it's much, much, much better to come out of an interview having written something than struggled for 60 minutes trying to get this optimal solution, getting nowhere, and ending the call with you not having written any code or gotten anywhere towards a solution. So spend some time trying to optimize up front, but if you don't see it in the 3 to 5 minutes after you see the naive solution, just start there, write it up, and then go forward. Something you should especially do is tell the interviewer that. Say, hey, I've got the solution. I think this is a naive solution, but do you want me to just write this up first? 95% of the time, they're going to say, yeah, let's write that first, and then we'll try to optimize it later. Because as an interviewer, I want that signal too. If you just sort of sit there struggling for 60 minutes, it's hard for me to be confident whether or not we should move forward or not. So the more signal that you're giving, the better. Another thing with an algorithms problem, if the solution seems too complicated, there's like 50 different edge cases that you're trying to take into account, it probably is, and it's probably wrong. So try to think about creating the simplest solution possible. Look out for ways that you can remove edge cases or further generalize the solution that you come up with. So again, we're going to go in much more detail on this interview later, since this is the bulk of what you're going to be doing in the process. So who can tell me some common classes of algorithms problems? So sort of like categories these might fall into. Yeah?
Search.
Yeah, so search problems. So like a graph search problem. That's a good one. Yeah?
Like greedy algorithm.
Yeah, greedy algorithm. That's a good one. Yeah?
Dynamic programming.
Yep, dynamic programming, super, super common. One more. OK, so here are the couple that I came up with. So the first is string. String manipulation is super common. So sort of knowing how your language of choice works with strings, how to reverse a string, index, substring, blah, blah, blah. Recursion, super common. A lot of greedy stuff can be is formulated as a recursive problem. Dynamic programming talked about. Graphs and trees, which are basically search problems. And then my least favorite category is which is basically math. We try to avoid these, but not all companies do, where it's sort of the solution just requires you to know some math thing off the top of your head, and there's some closed form solution that you're supposed to get. They're unfortunate, but they're definitely out there. And, a lot of interview books will have a section dedicated to just this. So the tools for solving these problems that you should really have down off the top of your head going into this interview. Sort of the principle here is that the less time you have to think about how to create an array in your programming language, that it's one less thing that you're worrying about during the interview process. So tools you should be aware of for solving these problems, how an array works, how to write up an array in your language, how a linked list works, hash tables, you want to know the built-in string methods off the top of your head. You want to be familiar with memoization and basic, caching abstractions within your language of choice. Know some sort of shortest path stuff off the top of your head. A lot of stuff you can generalize into just, you can fit it into a graph and then just run a search algorithm on that graph. So knowing this sort of fundamentals off the top of your head is really going to make your life a lot easier. And this is a really good list to start with. This is going to cover a lot of algorithms problems that you get. OK, so that's algorithms. So next is the coding problem. And it's basically the inverse of an algorithms problem, where getting the algorithm is probably pretty simple, but then coding it up might be a little more complex because there's a lot of nuances in the implementation detail. Maybe it's just a lot of code to write. But this is a problem where you might see the solution immediately. If you see a solution immediately, you should probably think to yourself, OK, I'm going to spend a lot of time writing code now to make sure I can cover everything. So a couple tips here. So the first thing, you want to decompose the problem as much as possible. Something interviewers look for is the quality of the code you're writing. If you just write a single function that has 200 lines, me as an interviewer, I'm going to look at that and say, OK, well, if we hired this person, this is probably what they would do on the job. Which we don't want. So really make sure that you're thinking a lot about code quality, not just the correctness of your code, but the design and style, as your CS50. So do things like create helper functions appropriately. Think about how you can simplify the code even more. If an interviewer has to prompt you, hey, do you see any bugs? That means we see a bug. Or do you see a way we could make it simpler? That means there's a way you can make it simpler. So try to get ahead of that and be proactive and look for bugs and look for those code quality improvements yourself. And again, familiarity with the language is going to help you a lot here. And we'll cover that a bit later. So the third type of interview is the practical interview. So broadly, a practical interview is you'll be given an actual code base, and often sort of a large code base, and you'll be asked to make some changes to it. So you could be given some app that has a bug in it, and your job is to just, like, never having seen this code base before, go and find the bug and fix it. This is really, really different than implementing something from scratch, because what this interview is trying to get at is your ability to reason about an existing code base, your ability to navigate code base, understand how different pieces of a system fit together. This isn't super common, but a lot of companies will do this, particularly on the smaller end. So some tips for this one. So really take the time to understand how different pieces of the code base fit together. So there could be 3 or 4 different modules that are used, and they're not all going to be relevant, but to the degree that they are relevant, try to understand what, sort of at a high level, why they exist and how they interact with each other. And this interview, that means you're probably going to spend more time reading than writing. You could, in a 60-minute interview, you could just read code for like 40 minutes, find the bug and fix it in 2, and then that's your 45-minute interview. In order to be successful here, you should be familiar with some development environment. Some companies will say, hey, bring your laptop, get ready to code in whatever development environment you want. Some companies will say, okay, you're going to use our laptop, but we're going to give you these 3 or 4 different tools. Be familiar with something so that you don't have to worry about an interview. Oh, how do I set a breakpoint, or what's the shortcut for doing this in the editor? Just be familiar with something. So again, it's one less thing you've got to worry about in the interview, so you can focus on the problem solving itself. A lot of these tools will have stack traces as a tool. So if you're ever wondering, you're inside some function, you're wondering how did I even get here? A trick I like to do is just throw an exception or just divide by 0 and then run it, and then you'll get a nice stack trace of how you got to that function. So that can be pretty useful in understanding how these pieces interact. The fourth is a systems design interview. So this, again, it's not as common for interns and new grads, but a lot of companies still ask it. You can basically think about these in 2 categories. The first is some technical system design. So someone might say, how would you architect the Gmail app? What they're asking you is, what classes would you create? How those classes interact with each other? What are all the parts of this system that need to exist? Or it could be a product design question. Could say, what feature is missing from Gmail? If you're applying sort of a product role or even an engineering role with a heavy product focus, you'll probably have to answer questions like this. So some tips there. The first thing you want to do is understand the constraints of your system. So you should never start by going right into design. You should start by asking a bunch of questions. So if someone says, how do you architect the Gmail app? Start asking a bunch of questions like, okay, what constraints do we have to worry about? Do we have to worry about network latency? Do we have to worry about low-end devices? Do we have to worry about the enterprise use case? We just focus on consumers. And just ask a bunch of questions like that to really narrow down the space that you're thinking about. So if you try to think of too big of a space at once, you're just not going to make a ton of progress. Second thing is be aware of any assumption you're making. So for example, especially if someone asks a question about some common product, you might have a bunch of assumptions because you might have used that product or had some ideas about it. Just sort of state those out loud. So you could say I'm assuming that we're working about the Gmail app on mobile, and by app you didn't mean desktop. And an interviewer would say, yeah, I'm just worried about mobile. But if you just go off and only think about one platform, your interviewer actually wanted to do some sort of cross-platform thing, you just wasted a bunch of time going the wrong direction. So state any assumptions you're making out loud, verify them with the interviewer. There's really no downside to doing this, and you really make sure you're on the right track. Then next, think of the consequences of any decision you make. So you could say, I want to introduce this, a class that does this. Think about, okay, what are the consequences of that? Does that mean that this other class is suddenly harder to do? Does that mean that this other feature now can't be accomplished? So don't just sort of propose one thing. Once you propose something, then think about sort of one step ahead and the consequences of doing that. Because if you don't, your interviewer is just going to do it for you. And you might sort of catch yourself making mistakes before your interviewer has to point them out. Along the same line, challenge your own ideas. Again, your interviewer doing this type of interview, their job is to just poke a bunch of holes in your system, and your job is to make sure that there aren't that many. So the more that you're challenging your own ideas, you're going to discover weaknesses or limitations of your solution that and sort of cover those proactively, which is much better than an interviewer just sort of telling you exactly what's wrong. And finally, just along the same line, just consider how future-proof anything you're doing is, that you're not painting yourself into a corner, because then an interviewer could introduce some new use case 5 minutes later that suddenly you're in trouble because you didn't think about what could happen in the future. Okay, and the last one is culture. So this is often called the behavioral interview, probably going to be happening towards the end of the loop with someone like me who's a hiring manager. And what we're trying to figure out here is essentially, what are your values, and do they align with the values of this company? Again, a lot of times this isn't an objective thing. People have different values, and companies have different values. So we're just looking to see if there's going to be a fit. And ultimately, what I want to know is, if we hire you as an intern for next summer, will you be successful? Because we want you to be successful. You also want to be successful, and so we want to try to match that up. So, rarely will I say something like, "What are your 5 values?" Because that's not a good question. So the way that we get this signal is sort of 2 categories. The first is looking back, and the second is looking forward. So by looking back, that means we're going to talk about your past internships and projects. If you don't have any internships, that's fine. You've taken classes. We're probably going to talk about those. If you have taken internships, be prepared to talk about your most recent one, since that's probably the easiest for you and the most interesting for me. So questions I might ask are, what went well in your past internship? What didn't go well? If you tell me like, nothing went well, it was the worst. Yeah, well, I'm a little worried about hiring you. If you said everything went well, it was perfect, I'm still a little worried, because I bet it wasn't. There's probably things you could have done better. I want to talk about the hardest challenges you faced. I also want to talk about how you overcame them, so we can see your approach to solving hard problems. So having an example off the top of your head is really great. One I really like is, what would you have done differently now? So if you were to start this internship over today with the benefit of hindsight, what would you have done differently? We really like to see people who give this a lot of thought and reflect and can self-improve. So these are the types of questions you should be ready for. Just think about these in advance, so you don't have to think of something on the spot. These are easy to prep for. And then the other half is looking forward. So basically, this job or this role that you're interviewing for, let's talk about that. So a really easy question is, what makes you interested in this company? If you say, well, I don't know, I live next door, which someone has said to me in an interview. Not a great answer. We're looking for something around, along the lines of, maybe you really like the product, maybe you really like the people, maybe, there's other things you're considering. So, we want to hear about those. We want to hear your honest answers. What do you want to work on? Some people come in saying, I really just want to work on front end. That's my goal. Other people say, yeah, I don't really know, and I'm sort of flexible. Again, we just want to hear this and hear that you've thought about it and make sure that there's a role. I might ask about your goals, either for this internship or sort of your long-term career goals. And I might ask, what are important aspects of culture to you, particularly if you worked at some past internship that maybe went well or didn't go well. I want to hear sort of organizationally what happened there. So in preparing for these, definitely take some time to reflect. Like I said, you don't have to come up with these all on the spot. Think about them in advance. Have some stuff ready. One framing I like to think about in preparing for these is just think about your ideal day. As an intern, what does your perfect day look like in terms of what you're doing, who you're working with, the types of projects you're working on, the environment around you, all that kind of stuff. It's a really good jumping off point. Avoid being overly negative about the past. Even if you did have a not-so-great internship experience, really not a good move to sort of rant about it in an interview. As an interviewer, if someone's ranting to me about some past internship, my first thought is, well, if they don't have a good time here, they're going to do the same thing, and that's not going to be good for us. So just don't. I think it's okay to be honest and say, yeah, here are some things that went well, here's some things that didn't go well, but don't just sort of go off on a rant. And finally, if you're under an NDA and you can't talk about what you worked on, that's completely fine. Just say so. Some people don't say that they're under an NDA or just, sorry, I can't talk about that. And they sort of dance around it. And I'm just sort of well, I don't even know. Maybe you're just a bad communicator. So if you have an NDA and you can't, a lot of people don't say this. So if you're, that's totally fine. We're not going to look down on you. It's not your fault. It's not a reflection on you. Just say yeah, unfortunately I can't talk about that, but I can talk about this other thing. Okay, so I'm going to hand it over to Ryan.
All right. So now we're going to talk a bit about the interview itself, and we're really going to focus in on the technical interview, which is kind of, I guess, the thing that a lot of people get really stressed and intimidated by. So first, let's talk about how do you prepare for your interviews. So there's 2 ways you can think about this. You can think about in the short term, you have an interview in a few weeks, what are you going to do to get ready for it? And you also kind of think about the long term, planning ahead, in the next few years, what do you want to do to make sure that you're going to have the best career opportunities when you graduate and for the next summer. So let's start with the short term. So I think one of the biggest things is just to get really solid in your basics, right? So if you're looking at some problems, you want to make sure that you have a language that you know really well, and you know how to do everything, all the basic operations. So say you want to know how to get the characters of a string in your language. You want to be able to let's say make a graph in this language. You want to be able to define a class, an object, and a node. You want to be able to sort some numbers. You want to be able to do that basic stuff so that when you're in the interview, you don't have to like fumble around and think, oh, how do I do this? How do I do that? You really want to just have as few concerns as possible so that you can really focus in on just what the interview is asking, like looking at the algorithm, looking at your coding, looking at your style of your coding, as opposed to kind of worrying about the basics and the syntax of the language. So yeah, so a few of the things I mentioned here, you want to insert, remove things from a linked list, store array, print stuff, BFS, DFS, know how to use a hash table, a dictionary in Python, for example. And I guess one thing I'd add on to here is try and pick a language where this is really easy. I have some people who try an interview in like C++, and they like just take like a really long time to write their code. They don't know C++ super well. They like did one class in it. I really recommend, if possible, try and learn like a nice interpretable language, something like Python, JavaScript, that you can really iterate quickly on and kind of interview well in. Yep. So another really big thing is to do a lot of practice, right? So you can do practice problems from the internet. There's a lot of sites about this. I'm sure you've all heard of like, I don't know, there's like HackerRank and all these other things where you can go on the site and just find a ton of problems. I think this is a really good way to start. I think we're giving out some Cracking the Coding Interview books at the end too. There's a lot of good problems in there. And you want to kind of identify common patterns that you see over and over in these problems. And one thing I'd suggest when you're doing these is to really practice efficiently. So when you're doing the problems, don't just like try it for like 5 minutes and like, say like, I have no idea what's going on. I'm just going to go look at the solution. I'm going to memorize the solution. So don't do that. I know a lot of people kind of prepare like that. And it kind of just prepares you to do the same thing in the interview. Like you run into something you haven't seen before. You're just like, I don't know what to do. I'm going to freeze. I can't look up the solution now. So you don't want to get in that position. You really want to train for what you're going to do in the interview. So I really suggest like taking maybe like 30 minutes when you're doing these practice problems to try and really focus in and figure out how you can learn from the problem and learn how to do it better the next time. And be kind of like retrospective after you finish the problem and look into what you're going to do next time. Another thing is make sure you're looking at a variety of problems. Don't just focus on graphs or just focus on dynamic programming. You want to get like a very wide range because you really don't know what companies are going to ask you ahead of time. All the things that Tommy had mentioned about earlier. There's also a lot of different data structures you should know. Mainly, I would say probably hash tables, graphs composed of nodes, linked lists, maybe a trie, like a tree of sorts. So basically, when you look at a problem, you kind of want to iterate over all the different things you can do and figure out like which one makes sense. One thing I see that people sometimes kind of do is they kind of go down one route really, really deep at the beginning of the problem, and they're kind of just going down the wrong route. So when you look at a problem, you want to have a idea of like all the big variety of things that you could be doing for this problem. So you kind of want to start and think like, hey, does it make sense to use a hash table here? Does it make sense to make a tree? What are the different options I have? And I kind of like to start with kind of a breadth first approach because usually when you have a problem, it's not going to be super complex. Like we don't have time to write like a 400-line program. Usually the solutions aren't too complicated. So if you try it and it's not working out too well, it's a good idea to just try something else and really look at all the different options before really diving down into a single one. And this is, I think this is just a lot of the things we talked about earlier. I think there's actually a duplicate slide. There might have something went wrong here. And lastly, you want to really be focusing in on what you're not doing well. So if you're handling those string problems fine, don't do it, practice over and over. You'll want to focus on what's not going well. So if every time you do a dynamic programming problem, you don't feel like you can't get it, just practice like a ton of dynamic programming problems, and eventually it'll start to make sense. Cool. And lastly, try to practice in a realistic setting. So as much as possible, you can try having your friends give you mock interviews. Try to, there's some tools online actually where you can even go and like real people will interview you. I think it's like coding, I actually forget the name, interviewing.io, I think. And you can kind of really practice with real people. I think it's, there's a lot that changes in a real coding environment. You get nervous, you kind of freeze, and you kind of want to practice this ahead of time so that when you go into a real interview, you kind of feel at ease because you've done this so many times. And this is kind of what we talked about earlier. You really want to try and take a long time on these problems. Don't just look at the problem, get the solution, memorize the solution. Focus on like kind of training yourself to how to problem solve, because that's really what we're going to be looking for later in the interview is your problem solving ability. And it's not like have you memorized how to write Dijkstra in C++. That's not what we're looking for. We're kind of looking for can you take a problem and take it apart and know your toolbox and kind of solve the problem that way. Yeah. So figure out like what went well, ask your friends for feedback. One small note here is sometimes people ask us for feedback at the end of the interviews. We usually cannot do this just because we're like afraid of like saying bad things and like getting sued for some reason. So you'll have to ask your friends ahead of the time. A lot of times people ask me in interviews, I can't, like, it's kind of awkward. I can say like, oh, I think it went great. The recruiter will get back to you later. Just because we really just like can't tell you, unfortunately. Cool. So I think another big thing is the long term. So you can kind of cram a bit for your interviews, but what's really going to make you a really good candidate is actually being really good at programming, right? Because that's kind of what we're looking for in the end result. The algorithms interview is kind of supposed to be a proxy for how well you're going to do at your job. So the best thing you can do is just get a lot of experience programming. And this can come from a lot of different sources. It can come from doing things like your practice problems. It can also come from your classes. So taking a lot of data structures and algorithm classes, doing these mock interviews, and really just working on becoming a better programmer. I think algorithm interviews kind of sometimes nowadays get this bad rep of like being kind of this one-off thing that you just prepare for the interview. I think ideally, that's not the case. I think for good companies, the interview is really trying to judge how well you are at programming. So just get better at programming. And when I was interviewing, to a degree, you can think about it like if they're not testing how well you are at programming, do you really want to work there? Like, are those people that you want to work with if they're just like testing how well you can memorize? So really focus on just getting better as a programmer in the long term. Cool. So now we're going to talk specifically about how does the technical interview work? So what is the structure? What can you expect in the algorithms interview? So first, we have the preamble. This is kind of often is kind of a shorter version of what Tommy talked about earlier with the culture interview. So we're going to ask you like, what have you worked on before? We might ask you about like maybe like describe a challenge you've had in the past and like how you resolved it. And in this case, we're really looking for the same things earlier, like how well do you work with a team? How well do you communicate? Oftentimes, the way this will work is we'll just ask you a bunch of things about your resume, like, hey, I see you've worked at Microsoft on their search team. Can you tell me a bit about what you did on that team? And you should be ready to really talk about what you've done at your past projects or your past internships, and prepare to give good answers. One thing I would suggest is kind of think about why you did things at previous internships. Sometimes I'll ask someone, hey, why did you decide to use like Redis in your internship project? And I'll get an answer. It's like, I don't know. My mentor told me to use Redis, so I did. So that's not a great answer. You really want to try and have a solid understanding of everything you worked on and be able to have a good conversation with your interviewer about the choices you made and how you thought about things, maybe about who you asked on your team, on suggestions, all that sort of stuff. One thing though, do try to keep it short. Something to remember here is that the main point of this interview is to judge your algorithm skills and your coding skills. So if you spend like 20 minutes telling me about your previous internship, and I like keep trying to interrupt you, say, hey, we should start doing the algorithms and stuff, and you just like keep talking. I've had people that do this like somewhat frequently. You're not going to have as much time to your algorithms section. It's just going to reflect poorly on you. Because we're doing our best to like kind of normalize for this, but at the end of the day, we can only see what you actually get to code. Cool. So after that, we'll get to the main meat of the interview, the technical problems. And specifically when you're talking about the algorithms section that Tom mentioned here, not so much the coding. So I'm going to talk a little bit about why do we do algorithms interviews. I think maybe if you've been reading on the internet a bit, you've seen some of these interviews get a fair amount of criticism from people saying like, oh, these are like not reflective of real world coding. So why do we give all these interviews? Why is everyone in the industry giving algorithm interviews? So I think the root of it is that we're really looking for some common knowledge among all students, right? So when we're looking for a new grad or an intern, we're not looking for someone who can immediately start and like take over running our infrastructure, right? We're really looking for someone who can work at the company for several years and kind of learn and grow as an engineer. So if we just go and we ask you like the details of how AWS EC2 instances works in an interview, that's maybe like that tests your knowledge, but it's kind of like, it's not going to be equal over all students. It's not really going to predict like how well you're going to learn and grow as an engineer in the future. So that's kind of why we kind of focus on this data structures and algorithms, because everyone takes the data structures and algorithms class. So it's kind of this common expectation. And so we're using it as this imperfect proxy. We know it's imperfect, but we haven't found anything better, so we're going to keep doing it. So what should you expect? There's going to be at least one coding problem focusing on data structures and algorithms. You may get more in the interview. You may get you will never get less. So there's 5 things you should really focus on here. One of them is explain your algorithm, your approach, and its correctness. So you should do this before you start writing your code. So don't just like start writing and then when you're done, like say, oh, hey, I think this works. Some people do this. You should think about it, maybe even draw it on the whiteboard or something, and talk through it with your interviewer and make sure they understand what you're saying. You should be able to analyze the space and time complexity of your algorithm. This is in terms of big O notation. So this is how much memory does it take in RAM, how long does the program take to run as the input size grows. You should be able to write clean code in an editor or on the whiteboard. So some people don't realize that we're looking for this. They think that we're just looking for the algorithm. Even when it is an algorithms interview, you should still be writing clean code. We'll talk a little bit more about this later. And even on the whiteboard, sometimes you can shorten stuff just because you don't have as much space, but still try to write as clean as possible. And lastly, in some coding interviews, you also may have to actually test your code. I think it's becoming increasingly common, especially with a lot of phone interviews nowadays, that you actually run your code in an environment and verify that it's actually working. And then lastly, we're going to have this closing. And this is really time for you to ask questions. Time went over a lot of this stuff earlier. Really just make sure that you're actually asking questions. You're still being judged at this point. Some people don't realize this. They think it's all about the algorithms. I think maybe it's perhaps overemphasized nowadays. There's actually a huge portion of your interview which is really just focused on the culture and the culture fit and similar. So make sure you ask good questions here. Don't ask, like, I've had someone ask me, like, is your office in the Bay Area? Please do like basic research ahead of time. You shouldn't be asking this stuff at the end of the interview. Yeah, so I think Tommy's covered this a bit, so we're going to skip this for now. Cool.
So we're going to do first mock interview. So we're going to do an interview where Ryan is going to interview me. Then we're going to talk about what went well and what didn't. Then after that, go into a bunch of sort of more formal tips and tricks and strategies for the technical interview itself. So So this is a tool called CoderPad. I don't know why it output Python 3.6 a bunch of times, but it did. So this is a pretty common tool that people will use for technical phone screens. But you'll sort of log in, you'll get a shared link with your interviewer, and they'll be on one end sort of talking to you, you'll be on this end, and you can both see the code that you're writing. Okay, so Ryan is going to interview me, and then we'll go from there.
Cool. Hey, Tommy, how's it going?
Yeah, I'm here.
Oh, actually, were we skipping the preamble? I think we did it last time.
Yeah, just go.
Okay, yeah, okay, cool. So we're going to skip the preamble so we don't spend like 10 minutes talking about Tommy's background. All right, cool. So let's get started with the problem. So today your task is to make a program that takes as an input an integer, and then you want to produce the nth Fibonacci number in binary format. Does that make sense?
Yep.
So do you want to talk about your program?
No.
All right.
Yeah, 1 sec. Okay, okay, that's the Fibonacci, and now let's do the binary. Yeah, and that's the binary.
All right.
good.
All right. You want to get? Do you want to test it? Maybe.
Then it's gonna work. It's like, that's right.
Did it run?
Do you want that or no?
Yeah. You can. Let's just try printing a sample test. Maybe like 3.
Fine. Oh, you said 3, but I'm going to do 5. So I like 5 better. All right, that's a couple of 1s, so that's binary. So if I think about the 5th Fibonacci number, well, it's 0 indexed, obviously, so it's really the 4th. So 0, 1, 1, 2, 3. Well, I mean, 3 is 1, 1 in binary, so that's it.
Why don't we? Let's try 8, maybe.
Why?
I think we should just try some other outputs.
There you go.
So that's not quite right, is it?
All right. Oh yeah, no, I know. I got this. No. Oh. Oh no. It's just.
So one thing to notice is that there's no 1s or 0s in your output, right?
Yeah, no, I know. It's because that. Oh no, if I just I'll flip these.
So why don't we try stepping through the program?
Yeah. No, I mean, you can. There's like the fib, and then there's the binary, and then you do them in that order. So this will do it. Okay, we'll cut there. Okay, so let's talk about. I know, really stellar. So let's talk about what went well and what did not. So feel free to raise your hand. Yeah.
You didn't really listen to the interview at all?
Yes, did not listen at all. So the interviewer was trying to help me along and say, like, here, you should try this case, or you should, sort of trying to guide me, and I just sort of ignored him entirely. What else? Yeah.
Your code is recursive instead of iterative.
Yeah, that's pretty. The code makes no sense, is sort of how I would generalize that. Yeah, the code is just flat out wrong, so don't do that. Other things that didn't go well or did well? Yeah?
You kind of jump straight into the code without like talking about it first.
Yeah, exactly. So you can see there what I did is I made an assumption. I made a bunch of assumptions I didn't clarify up front. I assumed that like it's 0 indexed, or well, I don't know. I said it was 0 indexed, and then I didn't start by asking any questions. With Fibonacci, that's like a very obvious clarifying question. I just sort of jumped in and didn't ask any of that. What else? There's definitely other things. Yeah.
I really like your attitude overall. Made you seem you didn't want to be there.
Yeah. So I was very flustered or stressed out. Like when it didn't work, I just sort of like freaked out and just started changing things randomly. Like I didn't really reason through the code or try to understand what was happening. I was just sort of flipping random signs and hoping it was going to work. At no point did I explain what my code was actually doing or try to run through it in my head and explain my approach. I just sort of kept running it, changing random things, run it again, which doesn't really give anyone confidence that I have any idea what I'm doing. How about one more, good or bad? Yeah?
Your test cases, you didn't do extreme values or like possibly like -1 or anything?
Yeah, definitely. So my test cases were just sort of like Ryan actually suggested a test case that I ignored, and then this is by no means comprehensive. I just sort of like printed it out. That's not a great way to do that. So I didn't reason through edge cases at all. So okay, so let's jump back and talk about concretely some strategies and things to do differently.
Cool. Yeah, so that was not so great. So let's talk a bit about what should you do. So we talked a bit about like what the negative examples here. So what you should do is you should make sure you understand the problem. It's extremely common that you, as an interviewer, I will ask a question, and the interviewer does not actually immediately understand the problem. So one good way to do this is to take an input and make sure that you and the interviewer agree on the output of that input, right? So for example, in this Fibonacci program, it would have been good if Tommy had verified that it was 0, 1 index and verified like, hey, how do you want this? Should it be 3 or should it be 1, 1, 1 for input 5 or whatnot? And you should also ask some clarifying questions. I think you can save yourself a lot of time here by just making sure that you really, really, really understand the problem. A lot of times people think it's more complex than it really is, or the problem, you need to handle more test cases. You can like say, hey, do I need to cover negative numbers as well? Do I need to handle the null case? Do I need to handle like very, very large numbers? And this kind of, it gives your interview like good signal that you know what to look for in a program as well when you're asking these questions. And let's talk a bit about brainstorming. So we touched on this a bit earlier, but one thing to remember here is that your process is really more important than your output. If you, for example, if the most optimal solution requires a heap, and you're just like not familiar with the heap, and you find like some suboptimal solution that uses like a sorted list, you're not going to get dinged much on that at all. Like maybe not even at all. Like if we're really primarily looking to see like how well can you reason through a problem, we're not looking, have you memorized this algorithm, have you memorized this data structure. Those things you should do because it makes it easier to get through these problems. But that's not the goal of the interview. The goal of the interview is to understand how well will you operate in a real programming environment. So you should go through a couple different approaches, starting with the easiest thing. So get the brute force solution, like try every possible input and just run a verification on it. Start with that because sometimes maybe that's like the best thing that the interview is looking for. Like I've had interviewers ask me questions that were like had closed form solutions, but they didn't want to know the closed form solution. They just wanted me to like do a search implementation or something similar. So really, even if you think it's really simple, you should just state the simplest solution first, and then go from there. Drawing diagrams and test cases helps a ton. I would suggest if you're doing a phone interview, have paper next to you. I find it's a lot easier to diagram trees, diagram your string problems on paper as opposed to using your laptop. It's just so much faster to iterate, especially on something like a graph problem. And then when you're doing your interview, even if you're going to code on a laptop and there's a whiteboard there, it's a good idea to like draw it out on the whiteboard, not only for your own benefit, but also so that you can kind of explain your process to the interviewer who's trying to understand how well do you work through these problems. And lastly, make sure you do explain at a high level what your approach is going to be. Don't just like start writing your code. Make sure your interviewer and you agree that it's a good idea to write the solution before you start doing it. Cool. Let's talk a bit about writing the code too. So again, just like the last slide, your process is more important than your output. So we're really looking to see how well can you work through a coding problem. We're not looking, for example, do you know whether there's like reverse is a function of a string or it's like a function that you call on a string. We're not looking to know like, we're not looking to see like how well you know your programming language in super depth. Like we want to know, do you have familiarity with the programming language? We don't want to know like, do you know the ins and outs of every part of that programming language? So let's see. Secondly, your code quality does matter. So do not call your functions foo, bar, and baz. If you come from a competitive programming language background, you should not just like use single variable programming variable names, because you're trying to show your interviewer what are you going to be like when you're on the job. So name your variables reasonable things. I also find that this actually really helps me when I'm coding as well. So especially when you're on the whiteboard, for example, you might need to like run through your code in your head. It really helps me if I've named my variable as something that kind of makes the program read like English. So for example, like if I have a complex logic statement, like if A and B or C and D, like I'll try to break it up into subparts, right? Like is number prime, is the string greater than 2 length. And some of this stuff like makes your code longer, but it really helps you kind of understand what's going on and read through it and verify that everything's working correctly. A big one is you should break your functions into helper functions. So if you can break down your problem as much as possible so you can test it in small parts, it'll really help you when you're going back later and you're debugging it, either in your head or on a real computer. So for example, in the Fibonacci problem, it's really, really good to define multiple functions, like to make a function that takes something, goes from decimal, goes to binary, produces the nth Fibonacci number. So break down your code. You'll find this helps a lot when you're on the job as well. If you write a really complicated program with really big state, it's going to take you forever to debug your program at the end. So try and keep everything as kind of separate and discrete as possible. Cool. Yep. So when you're coding on the computer, it's really, really hard to get something to work correctly on the first time. So you but you also want to make sure that it is eventually correct. So there's kind of this trade-off here. As we talked about earlier, helper functions will help a lot here. And one thing I suggest is that when you're writing your code, actually add your debug statements as you write your code. So the first pass, when I go through my code, sometimes I'll just include print statements so that I can verify that things are working as I expect, as opposed to going back and debugging later. I find this actually helps a lot for initial program writing speed. Yeah. And lastly, some final tips, just in general. You really want to over-communicate as opposed to under-communicate. Not only does this save us from this awkward silence where we just sit there and watch you code, it really helps with the thing we talked earlier about the process, that we're trying to understand what you're thinking. And if you run to a problem, it helps us understand that, like, hey, I'm thinking about this thing. I'm not just like, I haven't just like froze and I can't remember how to program or something. So try to communicate as much as you can. And remember, lastly, that it is not all about just solving problems and writing code. All the other stuff that we mentioned earlier about like being a nice person, communicating well, explaining your ideas, is all really, really important. I think a lot of this gets lost nowadays in the over-focus on the algorithm itself. Oops, it went the wrong way. And lastly, I'll talk a little bit about debugging on a whiteboard. There's some practical things you should watch out for. Just plan your code ahead of time. You have to worry about these practical things because you have like a fixed time limit. So try to not run out of space, write things. You want to spend a little bit more time planning when you're going to write on the whiteboard because you can't refactor it quite so easily. And you really want to practice debugging by stepping through in your head because you're not going to be able to have print statements and whatnot. I think this is actually a really good skill that I actually end up using in my job as well because it takes a really long time to compile larger programs nowadays. So this can be a very useful skill. You can do it by just doing one of your practice problems and then trying to figure out, is it going to be correct before you run the code? Because that's kind of what you have to do on your whiteboard problems to a degree. Cool. So now we're going to try a second mock interview where Tommy's going to interview me.
OK, so keeping all of those things in mind, so we're going to do a second interview here. I'll start fresh. And so this time I'm going to interview Ryan. And again, we'll talk about what went well and what did not go so well. OK. How's it going?
Hey, it's going great. How are you?
Great, good to hear. Ready for some technical problems?
Yeah.
Okay, cool. So for this first one, let's let's start by so you're gonna write a function, and it's gonna take as input some number, and it's gonna output the nth Fibonacci number in binary.
Cool. Let's see. So for the Fibonacci numbers, are we going from 1, 1, 2, 3, 4, 5? I'll just give an example here. So like do we say that this is, the top is the value and the bottom is the index? Is that what we're looking for?
Yeah, that looks right. Let's go with that.
Cool. Let's see here. So I think I'm going to first break it into two parts. We're going to start by computing the nth Fibonacci number. I think I'll do that iteratively and kind of build it up with an array.
Okay.
And then I'm going to do a second part. I'm going to transfer that number from decimal to binary.
Sure.
Does that make sense?
Yeah, that sounds good.
Cool. Let's get started here. So first I'm going to make the entry point. I'll call it fib binary. And we'll just leave this empty for now. So first, let's make a function that takes in a number and returns the nth Fibonacci number. So we know that the basic Fibonacci number is f of n equals f of n minus 1 plus f of n minus 2. So let's see. So if we were to do that just fully recursively, we'd probably run out of stack space for a large n. So I'm going to try and do it iteratively and maintain an array.
Sure.
So initialize it with the size of the number of elements. Let's see. And we'll start from 0 and build up. So for I in range, all right, and then we'll return the last element. And because we iterate up to n, we'll return n minus 1.
Sure.
Cool. And then next, let's take a decimal number and convert it to binary. We're making it into a string, right?
Yep, string should be
Cool.
your output.
So I think the way I'll do this is I'll just repeatedly divide it by 2 and take the modulus of a number by 2. So that should give me the trailing 1 or 0, and then I'll iteratively build up the number from there. So we'll do decimal is greater than 0. I'll make a ret decimal ret plus equals decimal modulo 2. I'll make this into a string. And then we will divide by 2. And then we'll finally return the result. Let's see, and we'll add some test prints as well. So we should be able to get the fourth Fibonacci number should be 3. So we'll print fib of 4, and we'll hope this returns. This should return 3. And we'll do the same thing down here. Let's say we'll turn 3 into decimal. So this should return 1, 1, I think. Okay, so let's run that and just verify that that works.
Okay, and let's just for a time, let's pause there. So let's hear feedback. So what went well and then what didn't go well? Yeah.
Pretty much every process was executed.
Yeah, exactly. So you sort of said up front, here's what I'm going to do. Does that sound right? Yep. Here are the inputs and outputs. Does that sound right? Yep. And so he sort of communicated throughout what his process was going to be. What else? Yeah.
The code like was really easy to read, but variables was really clear.
Yeah, exactly. So you sort of like broke it up into two very clear functions. It's very clear what each of these functions does. You could sort of read through it and understand it very easily. So this is pretty clean code for the solution. What else?
The code's correctness is pretty suspect.
Yeah, this is correct. I was going to debug it.
Yeah, so I think so this isn't correct. We just sort of cut it short because we're a little short on time. But yeah. What else? Yeah?
Good clarifying questions.
Yeah, exactly. So he clarified right up front what he wanted to do and not do, which was good. How about one more, good or bad? Yeah?
Separate functions.
Yeah, exactly. Sort of like nicely decomposed, easy to follow. Yeah?
I have a question.
Sure.
Say that a possible solution doesn't come to you immediately. Is it okay to kind of take some time to think to yourself, or do you recommend just talking before, like talking through it to find a solution?
Yeah, if you can talk it through, that's always better. Some people just sort of like, it really doesn't get to you, just like, oh, do you mind if I like take a minute and draw something out? I have some paper here. I think that's sometimes fine. Would bias towards always talking out loud if you can. We'll save some more time for some questions at the end. So let's just wrap up. Okay, so final section is the shortest one, is after the interview. One thing to keep in mind is that interviews are really, really high variance. Companies like Google do a lot of actually like A/B testing and experimentation from their like HR department on some of this stuff. And so people found that there are lots of really, really great developers who just don't do well in some particular programming interview. That's totally okay. So if you have some coding interview and it doesn't go great, don't get discouraged. It's totally fine. I'll never forget the first technical interview I did. It was for Facebook, and it was just really simple, just like traverse a binary tree. And I was taking 51 at the time, and I was like, oh, I'll do this in OCaml, and it just like completely exploded. The interviewer was like, what are you doing? And I was like, I don't know what I'm doing actually. And then it was terrible. And then I remember he was talking to the other interviewer like in the elevator, and I could hear them like joking how badly I did, which is like fine. Like everybody bombs these. It's totally fine. So don't get discouraged. The more practice you do, the more this is going to really start to come naturally to you. When you're writing code, speaking out loud and coding, it's not normal. Like when you're on the job, you probably don't do this, or the people like next to you are going to think you're weird. So it's really unnatural. It's not something that comes easily to a lot of people. But the more you practice and the more you just sort of like go through lots of reps of different practice problems, do lots of actual interviews are really going to help you the most. Other mock interviews with your friends or things like workshops like this, you'll sort of naturally start to develop these skills. But you're not going to be great out of the gates. That's totally fine. It doesn't mean you're a bad programmer. Your career is over. This stuff is hard, and it takes some time just to really practice through. So I just want to end with some takeaways from today. The first thing you should do, if you don't already, is pick some programming language that you are going to interview in and learn it. So all those data structures we talked about, all the different functions we talked about, sort of like syntactic sugar, just learn all of that for some programming language. Do not think about that during your interview. Next, fill out that toolbox. So not just language specifics, but know the difference between a breadth first search and a depth first search. Know just how to write that if you really need to. Know the basics, the runtime for accessing a hash table or a linked list. Just know this stuff off the top of your head. Third, do lots of practice problems. This is really the best way to learn, and I wish there was some sort of shortcut you could take, or maybe I don't because it makes my life harder. But you can't. You just really have got to do a bunch of practice problems and repetition and invest in that. When you're doing so, practice talking out loud. It feels really weird, but you just sort of get used to it eventually. And finally, keep interviewing. It's something that it takes a lot of time. You've got to go through it and fail some interviews. Everyone does, and that's really the only way to get better. So providing everyone at the workshop with this book. So this author is actually pretty prominent on Quora. This book is probably the best interview prep book out there. It's got tons of practice problems categorized into the things that we talked about today. So dynamic programming problems, strings, recursion, whatever. So that it helps you sort of understand what classes of problems that you're not great at, and sort of enables you to focus on those. And so that's all we have. We wanted to save lots of time at the end for Q&A. So if you've got any questions for us about sort of specific interview stuff, we'd love to talk about them right now. Yeah.
So what you were saying about the beginning about ranking skills, for example, if you have more experience working in some programming languages versus others, how should you address that on your resume?
Yeah, so as an interviewer, it probably doesn't matter to me, actually, like your relative skill on various programming languages. For most interns, we don't expect you to come in knowing some technology down really well. We expect that, you'll be able to learn a bunch on the job, and you don't need to be an expert in React Native going into your internship. We just expect that you've got your fundamentals and you're able to then learn that programming language. So What matters most is just the language you're going to interview in. Doesn't matter too much about like the relative skill sets outside of that.
Should we not list languages we're not comfortable interviewing in?
Yeah, I think it's not a bad idea. I think some sort of like mean interviewers have this rule that's like, if it's on your resume, I can ask you about it. So like if you put assembly on your resume, we're gonna like make you do a problem in assembly. That's sort of lame, but it exists out there. So broadly, I sort of like listing languages in like the order that you know them in. Some people like to say proficient or intermediate or whatever. I mean, my personal view is that it doesn't matter all that much, but yeah, don't list a bunch of stuff in your resume that's untrue or that you'd be uncomfortable talking with. But I think if you list a language and an interviewer says, oh, let's do this language, you can say, oh, just so you know, I'm not, I took it for this class, I don't know it super well, and I'm happy to give it a go, but this is the language that I'd like prefer to interview in. Yeah.
For classes, should we list any relevant classes?
Sorry, what's the question?
Should we list any relevant classes we've taken?
Oh, should we list any relevant classes you've taken? You certainly can. In particular, if you don't have a lot of internship experience, there's not a whole lot to put on your resume. Listing classes is pretty helpful. Many times the people like me who go to a school and talk to people will have gone to the school as well. So if you say something like I took CS125, that's like a meaningful thing to the interviewer. So it certainly doesn't hurt, especially if you don't have a lot of stuff else to put there. Other questions?
I'll definitely put like if you've TA'd a class as well, or if you've taken particularly like advanced graduate classes. I think that's definitely a signal.
Yeah. I think that's if you've taught a class, that's really, really great to see. If you're taking like graduate classes, that's great to see. Yeah.
If you really don't know how to do a question they ask, is it like fine to be honest, or do you give it like what's the plan of attack?
Yeah. So what do you do if you just like don't if you don't see it? Yeah. So a lot of interviewers want to help you, and so they'll sort of have hints prepared in their back pocket. So if there's some question and you just don't really see it, you can just say, hey, think out loud with your process. Like, okay, will this work? No, this doesn't seem like it'll work. This other thing work? Well, maybe it won't. And then interviewer one could like guide you based on that and say, oh, well, actually, what if you do this? Then does that approach work? Say, yes. Or sometimes you just say, hey, I'm honestly not seeing it. Do you mind giving me a little bit of direction? And interviewer will say, oh, sure. What if you think about it in this way? Definitely wouldn't say like, yeah, I don't know. I'm packing it in. Interviewers like want to help you, and so you say, hey, I'm not sure. I'm sort of stuck right now. Do you mind giving me a little bit of guidance, or do you have a hint to point me in the right direction, or something like that? Yeah.
Is it bad to like Google something if you like can't debug your code?
Yeah, that's a good question. Is it bad to Google something if you can't debug your code? It is only bad if you do not ask. So if you're doing a phone interview and all of a sudden I hear like silence on the other end and I'm like typing and I'm like, hey, what you doing? And they're like, oh, nothing. That's not good. Don't do that. Some interviewers really don't care if you're Googling things. Like some interview questions are designed for like, someone might need to Google something. That's totally okay. Others are not. Others, we don't want you to Google because you could like stumble upon the solution, and that's like obviously bad. So just clarify with your interviewer up front. If you're sort of stuck, you say, here I want to reverse a string. I don't remember how to reverse a string. Do you mind if I just Google it? Usually as an interviewer, I will say, no, don't Google it. Just pretend there's a function called reverse and use that, because that's much more interesting than like you taking some risk of like finding the solution. But just always be upfront with your interviewer. That's the absolute most important thing. And I think we had this on the slide too, but if you've seen a problem before, absolutely say that. A lot of people think they're gonna win the like best actor Oscar for like pretending they haven't seen a problem before. It is excruciatingly obvious when you've seen a problem before. So don't do that either. If you've seen a problem before, just say, hey, actually I was doing some practice problems and I've actually seen this one before. Do you want me to solve it anyway? Sometimes interviewers say, oh yeah, sure, solve it anyway. Like it's more of a coding thing than algorithms thing. Or sometimes interviewers say, oh great, thanks for letting me know. Let's do this other one instead. We've rejected candidates immediately who are clearly lying. So do not lie. Yes?
Could you guys talk a little bit more about how you decided, like, through your job search that you wanted to look at Quora and what made you eventually, like, take that offer? Is that something you can talk about?
Yeah, sure. So I'm talking that you should have a very different story than I do. So let's see. I went to Quora in 2013. The recruiter at the time actually used to work with CS50 as well. But for me, it was what I cared about most was sort of the mission of the company. Where before Quora, I did a lot of stuff with like CS50 and education and edX and all that. So I was really excited about sort of that mission of online education and learning. And Quora is one of the few companies operating in that space. That's also sort of in the consumer world as well. So it's not this like academic or enterprisey thing. It's like a consumer web company that moves fast and you can have a lot of impact, but also in a space that I cared a lot about. So that's why I picked Quora.
Yeah, I think for me, I think a lot of it was about the people. So I had known people who had graduated before me and gone to work for Quora. I knew that they had like a strong engineering reputation, and I think there was a lot of problems that were really interesting to me at Quora. So that was initially why I was interested in it. Yeah.
Other questions? Yeah?
Is it okay to like tell your engineer like, oh, I'm sorry, I'm really nervous, like it's my first interview, like, you know, what I mean, to like give your interviewer kind of an idea of how I'm feeling?
Yeah, so the question is it okay to sort of say like, hey, this is my first interview, I'm kind of stressed? That's a good question. I've actually never thought about this one before. So off the cuff, I don't think it's gonna help in the sense that like, even if it is your first interviewer, like that doesn't change the, the rubric of the question or something like that. Like, so, you probably will not get some outcome where like an interviewer like goes easy on you or something. So I don't know if there's a whole lot of value to that. If it like helps you feel better, like makes you more comfortable to say like, hey, I'm realized, no, this is a real thing. Like how you feel and your stress is really important. So if it makes you more comfortable to say that, then, there's not a lot of downside, but there's also probably pretty low upside as well. What do you think?
Yeah, I don't know. I think to be completely honest, you shouldn't fake being stressed to get better results, but we do take this into account when we're looking at the decisions. Like, if I see that you're crazy nervous, and I think part of that came into play when you're doing an interview. I think we do write that down in the feedback. So yeah, I guess technically it could come into account, but I don't know if saying that it's really obvious when you're nervous, so you don't really need to say it.
But it's okay if you're nervous. That's why doing a bunch of these is good. Yeah.
You mentioned that interviewers won't give feedback right after the interview.
Mm-hmm.
If you get rejected from the job, can you then ask for feedback, and will they be honest about how you could improve?
Yeah. So the question is, when is it okay to ask for feedback, even if they can't say it in an interview? Suppose you get rejected, can you ask for feedback? So this is an unfortunate reality. Is there's a lot of legal risk in a company divulging feedback about somebody. So for a company, there's really high downside and basically no upside. For you as an individual, there's a lot of upside in learning, but unfortunately, most companies just can't do it. So my advice would be to just not ask. Use these mock interviews, use interviewing with your friends, use interviewing with people who did get internships at some company, get feedback from them. That's sort of your feedback opportunity. If you do ask, you sort of put the company in this uncomfortable position of saying, well, we can't give you feedback. And some people push really hard. It's not really a great look. I wish that weren't the case. That's why we do stuff like these mock interviews where we can go all crazy and tell you exactly what you need to improve. But yeah, I wouldn't recommend it.
Yeah, for what it's worth, I've tried this and it didn't work, so.
Yeah.
I'm not sure if this would be applicable for this, but how similar would the algorithms and those type of coding questions be in more of a data science role? Would those be questions that could be asked there too, or?
Yeah. So the question is, how do these questions compare between data science and engineering? So typically with data science, they'll be less sort of coding heavy, since as a data scientist, you're probably not writing a whole bunch of production code, and people need to worry about are you testing things correctly. There's a separate set of questions which would be sort of here's some problem. How would you design metrics to evaluate the success of this product thing? Or questions that require you to write a big SQL query, for example, as opposed to Python. So I think it's sort of a different set of questions. All of the process stuff 100% applies, and vocalizing what you're doing, asking for hints at the right point, knowing the basics of whatever it is you need down cold. But you'll probably get a different set of questions.
Yeah, I think another thing that's different is, so I work in machine learning, so we're kind of the bridge between those two. So we get similar interviews. Is that there's probably going to be more knowledge-based interviews. So we do actually look to see how well do you know machine learning, how well do you know statistics in these interviews, which I guess we're not looking quite as much do you know infrastructure super well in your new grad interview, but we might look more for that in a data scientist interview.
Yeah.
Is there any book you recommend for data science roles, just a generic machine learning textbook?
I defer to you.
Let's see. I think the field's evolving pretty fast right now, so there's not a ton of really good books on it. I think I think there's a number of good online classes that you can take to skim through. Yeah, sorry, I don't have a good answer to that. I didn't use any books for preparing. So I don't know.
Yeah, so the question was sort of like books recommended for data science or ML. I think your best shot is probably courses. Like there's courses here you can take on ML and data science, and then those courses will point you to various resources. So I would start there. There's no, something like cracking the code review is sort of like your canonical answer for engine interviewing. For other stuff, there's no real canonical answer yet since the fields are sort of new.
Yeah.
Yeah?
For knowledge-based interviews, are they, like, what kind of questions are asked? Are they usually like, how much do you remember, and also how do you best prepare?
Yeah, so the question is, so for these knowledge-based interviews, like what types of questions are asked?
Mm-hmm.
We probably can't tell you exactly what we ask.
Yeah.
We can give you a flavor.
I think it's going to be like, do you understand like the key algorithms used in machine learning and statistics? So like, we probably will not ask you to like implement. Sorry, I can't give like too many specifics.
Yeah, I could try to give some examples. So for some eng roles, like mobile, for example, like mobile is a very specific domain in the same way that like data is a specific domain. And so we might ask questions about like parts of the framework. So like when do you use this API versus this other APIs, or like what are trade-offs between these two APIs, or what's an API within iOS that you think is badly designed? So they're not really like gotcha-y. They're just sort of like, hey, can you demonstrate a depth of understanding in this field? But yeah, hard to give too many specifics, unfortunately.
Yeah, I guess so. For machine learning, I guess we could ask like, when should you be using linear regression versus a neural network? What are the different upsides and downsides? That would be a very basic question, but similar things like that.
Other questions? Okay, well we're almost at time anyway, so we'll hang out here for another 5 or 10 minutes if you have any questions for us that you want to talk through. And if not, then thanks so much for coming.